Hello and welcome to the channel Science, Maths and Engineering. Today we are going to solve the APSC Irrigation 2021 Mechanical Engineering paper part 3. So let's get started. So till question 50 we have already solved. So today we are going to start from question 51. Okay. So choose the wrong statement. A. Among all heat engines operating between a given constant temperature source and a given constant temperature sink, none has higher efficiency than a reversible engine. Okay. B. The efficiency of a reversible heat engine operating between a given constant temperature source and a given constant temperature sink is 100%. C. The efficiency of a reversible engine is independent of the nature or amount of the working substance undergoing the cycle. Or D. A reversible cycle is an ideal hypothetical cycle in which all the processes constituting the cycle are reversible. So you can pause and think of the answer. So the answer is B. If we see, the efficiency of any reversible engine cannot be 100%, so it violates the Kelvin-Planck statement. And whereas statements A, statement C, D are all true statements. Statement A denotes the Carnot theorem, statement C is derived from a corollary of the Carnot theorem, and statement D is what partially defines a reversible cycle. So if you have any more doubts, you can follow the source. So we will go to the next question. The efficiency of Rankine cycle is given by this H1, H2, H3, H4 have their usual meanings. So it is given by A, H1 minus H2 minus H3 minus H4, okay, whole bracket divided by H1 minus H4. B, H1 minus H2 plus H3 minus H4 within brackets, everything whole in bracket and then divided by H1 minus H4. C, H1 minus H3 in bracket minus H4 minus H2 in bracket, the whole thing also in bracket divided by H1 minus H4. Or D, H1 minus H2 in bracket plus H4 minus H2 within bracket, whole thing in bracket divided by H1 minus H4. So you can pause and think of the answer. So the answer is B. The efficiency of Rankine cycle is given by efficiency is equal to H1 minus H2 within bracket minus H4 minus H3 within bracket, whole thing within bracket divided by H1 minus H4, which is again equal to H1 minus H2 within bracket plus H3 minus H4 within bracket, whole thing within bracket divided by H1 minus H4. Here H1 is the enthalpy of the steam coming out of the boiler, H2 is the enthalpy of the steam coming out, means coming out of the turbine. H3 is the enthalpy of the water that is entering the pump, and H4 is the enthalpy of the water after being pumped. So H4 is greater than H3. Okay. So in case if any more doubt, you can follow the source. So we will go to the next question. The efficiency of Otto cycle is given by A, 1 minus 1 by R to the power k minus 1, and the notation is gamma down. B, 1 minus 1 by Rk to the power gamma minus 1. C, 1 minus Rk to the power gamma minus 1 whole, divided by k, and D, 1 minus Rk to the power gamma minus 1 whole thing divided by gamma. So you can pause and think of the answer. So the answer is the efficiency of Otto cycle is given by 1 minus 1 by Rk to the power gamma minus 1. Now here Rk is the compression ratio, and it is given by volume at the beginning of compression divided by volume at the end of compression. and gamma is the ratio of specific heat at constant pressure to the specific heat at constant volume, that is Cp by Cv. Now for air, gamma is equal to 1.4. Okay, so if you have any more doubt, you can follow the source. So we'll go to the next question. For the same compression ratio, the efficiency of air standard diesel cycle is A more than air standard Otto cycle, B equal to air standard Otto cycle, C less than air standard Otto cycle, or D none of the above. So you can pause and think of the answer. The answer is C. For the same compression ratio, the efficiency of air standard diesel cycle is less than air standard Otto cycle. So if the compression ratio is same, so the efficiency of Otto cycle is more than diesel cycle. However, if for the same maximum pressure and temperature, the efficiency of air standard diesel cycle is more than air standard Otto cycle. So in case you have any more doubt, you can follow the source. So we'll go to the next question. Nusselt number is given by A HL by K, B mu Cp by K, C rho VL by mu, or D V square by T Cp. So you can pause and think of the answer. So the answer is Nusselt number is given by nu is equal to HL by K. Here H is the convective heat transfer coefficient, L is the characteristic length, and K is the thermal conductivity. Okay. So if you have any more doubt, you can follow the source. So we'll go to the next question. A grey body of 1200 degrees centigrade is perfectly black surroundings at 500 degrees centigrade, has emissivity of 0.4 and 0.7 respectively at 1200 degrees centigrade and 500 degrees centigrade. The heat loss by radiation is, so you need to determine the heat loss. So we can pause and calculate the answer. So the answer is, we know E the energy transmitted by radiation is given by E is equal to epsilon into sigma to the power sigma T to the power 4. Now heat loss from the grey body at 1200 degrees centigrade, that is 1473 Kelvin, is E1 is equal to 0.4 emissivity into 5.67 into 10 power minus 8, that is the Stephen Boltzmann constant, into 1473 to the power 4. So we have determined E1. Next, heat gained by the grey body at 1200 degrees centigrade, which is released by the black body at 500 degrees centigrade, that is 773 Kelvin, is given by E2 is equal to 0.4 into 5.67 into 10 power minus 8 into 773 to the power 4. So E2, again we have determined the value. So net heat loss would be E is equal to E1 minus E2. Now if we calculate the answer, so our answer would be the value C. Okay. So if you have any more doubt, you can follow the source and you can calculate yourself and determine the answer. Okay. So we will go to the next question. Select the condition at which heat transfer from insulated tip can be considered the case of fin of indefinite length. Okay. So here we have some values of M and L. So we need to determine what is the condition. Okay. So here it can be considered as the case of a fin of indefinite length. So you can pause and calculate. So the answer is B. Now how we get it is that the condition at which the heat transfer from insulated tip can be considered the case of an indefinite length is that there is no heat loss from the tip. Now it happens when tan H of M into L is greater than or equal to 0.99, which implies M into L should be greater than or equal to 2.65. Now of option A, B, C and D, If we calculate m into L, so for option A it is 2.25, for option B it is 3, for option C it is 2.16, and for option D it is 2.4. Now only option B has a m into L which is equal to 3, that is greater than 2.65. So the correct answer is option B. Now in case you have any more doubt, you can follow the source and calculate it. So we'll go to the next question. Choose the correct statements. The thermal conductivity of pure metals decrease with increase in temperature. 2. The thermal conductivity of non-metals increase with increase in temperature. 3. The thermal conductivity of insulators increases with increase in temperature. And number 4, thermal conductivity of non-metals decrease with increase in temperature. So, which combinations are the correct answers that we need to determine? So, you can pause and think of the answer. So, the answer is A. Now, the thermal conductivity is given by K is equal to K naught into 1 plus beta into T. Now, K naught is the thermal conductivity at 0 degree centigrade. T is the temperature and beta is the temperature coefficient of thermal conductivity. Now, beta is greater than 0 for non-metals and insulating materials, and beta is less than 0 for metals. Therefore, the thermal conductivity of pure metals decrease with increase in temperature, while the thermal conductivity increases with increase in temperature for non-metals and insulators. Okay. So, if we see solution A, what does it mean? That the thermal conductivity of pure metals decrease with increase in temperature is a correct statement. The thermal conductivity of non-metals increase with increase in temperature is also correct. The thermal conductivity of insulators increase with increase in temperature is also correct. Whereas the thermal conductivity of non-metals decrease with increase in temperature is a false statement. Okay. So we will go to the next question. A flat plate has thickness 5 cm, thermal conductivity 1 watt per meter Kelvin. Convective heat transfer coefficients on its flat faces are 10 watt per meter square Kelvin and 20 watt per meter square Kelvin. The overall heat transfer coefficient for such a flat plate is A 5 watt per meter square Kelvin, B 6.33 watt per meter square Kelvin, C 20 watt per meter square Kelvin, or D 30 watt per meter square Kelvin. So you can pause and calculate the answer. So the answer is A. Now the convective heat transfer takes place on both sides of the flat plate and conduction takes place across the thickness of the flat plate. So the overall heat transfer coefficient is given by 1 by h1 plus delta x by k plus 1 by h2 to the power 1 by 2. That means the whole thing is 1 upon. That is u would be equal to 1 upon 1 by h1 plus delta x by k plus 1 by h2. Okay. So if we calculate, we get that u is equal to 5 watt per meter square Kelvin. Okay. So in case you have any more doubt, you can follow the source. So we'll go to the next question. The inner surface of a plain masonry wall is at 70 degrees centigrade and its other surface is at 45 degrees centigrade. Taking thermal conductivity of wall material as 0.5 watt per meter per Kelvin, the rate of heat dissipation per square meter of wall having thickness 200 millimeter is, so we need to calculate the rate of heat dissipation per square meter. Okay, so you can pause and calculate the answer. So the answer is D. How? The rate of heat dissipation per square meter of wall or heat flux is given by Qxn is equal to minus K dt by dx. Now Qxn is equal to how much? 0.5 into 318 minus 343 divided by 0.2, which is equal to 62.5 watt per meter square. So our answer is D, 62.5 watt per meter square. So in case you have any more doubt, you can follow the source. So we'll go to the next question. The dimensions of kinematic viscosity of a fluid are A. Length into time square, B. Length square time inverse, C. Mass into length inverse into time, or D. Mass into length inverse square into time square. Okay, so we can pause and calculate the dimensions. So the answer is B. The dimensions of kinematic viscosity of a fluid is length square per time, that is meter square per second. Okay, so if you have any more doubt, you can follow the source. So we'll go to the next question. A block of aluminium having mass of 12 kg is suspended by a wire and lowered until submerged into a tank containing oil of relative density 0.8. Taking the relative density of aluminium as 2.4, the tension in the wire is, we need to determine the tension. We have given that Z is equal to 10 meter per second square. So you can pause and calculate the answer. So the answer is D. Now if we see, we have a figure here. So the body is just immersed under the water. Okay, so now the downward force of this aluminium block is 12 into 10 12, so it is total of 120 Newton. Okay, now density of aluminium is how much? 2.4 into 1000, that is 2400 kg per meter cube. Now volume of the aluminium block we need to determine. Why we need the volume? Because that much of water has been displaced. Okay, so from that water displaced or the oil, or that much of oil is displaced, and from the oil displaced we need to find the buoyant force. Okay, so the volume of the aluminium would be 12 kg divided by 2400 kg per meter cube, which is equal to 0.005 meter cube. So the volume of oil displaced would be now equal to 0.005 meter cube. Now the density of oil is how much? It has relative density of 0.8, so its density would be 800 kg per meter cube. So the net buoyant force applied by this oil would be equal to the volume into the density, that is the mass of the oil displaced, into Z. So which is equal to 40 Newton. Now if we see that the aluminium block, the earth is pulling the aluminium block with a force of 120 Newton, but a buoyant force of 40 Newton is being applied by the oil. So the remaining 80 Newton would be the tension that is being there in the wire. So our answer is 80 Newton, that is option D. Okay, so if you have any more doubt, you can follow the source for this basic understanding and the equations. So we'll go to the next question. If I is equal to moment of inertia of the plane of a floating body at the water surface, V is equal to volume of the body submerged in water, comma, Bz equal to distance between the center of gravity and the center of buoyancy, B, and metacentric height Gm is expressed. Okay, if this is there, then what the metacentric height Gm is expressed as? So we have A, Bz minus I by V, B, V by I minus Bz, C, I by V minus Bz, or D, Bz minus V by I. So you can pause and think of the answer. So the answer is C. Metacentric height, that is Gm, is equal to I by V minus Bz. So that is moment of inertia divided by the volume of the body, okay, minus the center of buoyancy into the center of gravity. Okay, So if you have any more doubt, you can follow the source. So we'll go to the next question. If a vessel containing liquid moves downward with constant acceleration g, then A. The pressure throughout the liquid mass is atmospheric. B. The pressure in the liquid mass is greater than hydrostatic pressure. C. There will be vacuum in the liquid. Or D. The pressure throughout the liquid mass is greater than the atmospheric pressure. So you can pause and think of the answer. So the answer is A. If a vessel containing liquid moves downward with constant acceleration g, then the pressure throughout the liquid mass is atmospheric. Now what happens is that as the vessel containing liquid is moving downward at an acceleration g, it experiences weightlessness. That means the net acceleration is g minus g equal to 0. So the hydrostatic pressure that is there becomes 0. Thus the pressure throughout the liquid mass would be atmospheric pressure. Okay. So we will go to the next question. For an irrotational flow, the velocity potential lines and the stream lines are always A. Parallel to each other, B. Coplanar, C. Orthogonal to each other, or D. Inclined to the horizontal. So you can pause and think of the answer. So the answer is, for an irrotational flow, the velocity potential lines and the stream lines are always orthogonal to each other. Okay. So if you have any more doubt, you can follow the source. So we'll go to the next question. In an impulse turbine, A, the entire kinetic energy is converted to pressure energy at the inlet of the turbine. B, part of the kinetic energy is converted to pressure energy. C, no part of pressure energy is converted to kinetic energy in the inlet. Or D, the entire pressure energy is converted to velocity energy. So you can pause and think of the answer. So the answer is D. In an impulse turbine, the entire pressure energy is converted to velocity energy or kinetic energy. Okay. So if you have any more doubt, you can follow the source. So we'll go to the next question. Cavitation occurs in centrifugal pumps due to A. Very low suction pressure, B. Very high impeller speed, C. Both A and B, or D. Low discharge. So you can pause and think of the answer. So the answer is C. Cavitation occurs in centrifugal pump due to very low suction pressure, restricted suction, too high temperature of the flowing fluid, and very high impeller speed. Okay. So if you have any more doubt, you can follow the source. So we'll go to the next question. A Pelton turbine develops a power of P kilowatt at n RPM under a net head of H meter. Its specific speed is A. Capital N into P to the power 1 by 3 divided by H to the power 5 by 4. B. Capital N into square root of P divided by H square. C. Capital N into square root of P divided by H to the power 5 by 4. Or D. Capital N into P to the power 1 by 3 divided by H square. So you can pause and think of the answer. So the answer is C. A Pelton turbine develops a power of P kilowatt at n RPM under a net head of H meter. So its specific speed is N into root P divided by H to the power 5 by 4. So if any more doubt, you can follow the source. So we'll go to the next question. In order to avoid cavitation, A. NPSH required should be less than NPSH available. B. NPSH required should be greater than NPSH available. C. NPSH required should be equal to NPSH available. Or D. None of the above. So you can pause and think of the answer. So the answer is A. So NPSH means net positive suction head. So it is defined as net positive suction head is equal to Pi divided by rho z plus Pi square divided by 2z plus PV divided by rho, minus PV divided by rho z. So here Pi is the inlet pressure, Pi is the inlet velocity, and PV is the vapor pressure of the liquid. Now, this value is the minimum value required at the pump inlet to avoid cavitation. So, in order to avoid cavitation, the available NPSH should be greater than the required NPSH. Okay. So, if you have any more doubt, you can follow the source. So, we will go to the next question. Draft tube is fitted with which of the following purposes? A. To control the flow rate of water. B. To recover part of kinetic energy of water. C. To guide water out of turbine. Or D. To avoid splashing of water. So you can pause and think of the answer. So the answer is B. Draft tube is fitted to recover part of kinetic energy of water. Okay. So if you have any more doubt, you can follow the source. So we'll go to the next question. Odometer in automobile is used for A. Circulation of fresh air and removing carbon dioxide. B. Indicating fuel consumption. C. Indicating temperature of air cooling. Or D. Indicating distance traveled. So you can pause and think of the answer. So the answer is odometer is in automobile is used for indicating the distance traveled. Okay. So if you have seen behind your steering wheel, there is the odometer which gives you the amount of kilometer you have traveled by the car. Okay. So we will go to the next question. 1 ton of refrigeration TR means A. Capacity to freeze 1 ton of water from and at 0 degree centigrade. B. Capacity to freeze 1 ton of water from and at 0 degree centigrade in 24 hours. C. 1 ton of the refrigerant used. Or D. None of the above. So you can pause and think of the answer. So the answer is B. 1 ton of refrigeration TR means capacity to freeze 1 ton of water from and at 0 degree centigrade in 24 hours. So it has to freeze at 0 degree centigrade, the water would be there. So it has to freeze it into ice within 24 hours. That much is 1 ton of refrigeration. Okay. So if you have any more doubt, you can follow the source. So we'll go to the next question. A Carnot refrigerator has COP equal to 5. The ratio of higher temperature T1 to lower temperature T2 is A 6/5, B 5/4, C 5/6, or D 3/2. So you can pause and calculate the answer. So the answer is A. Now COP of a reversible refrigerator is given by T2 by T1 minus T2. T2 is the desired effect and T1 minus T2 is the work input in terms of temperature. So COP of the reversible refrigerator would be equal to 1 by T1 minus T2, T1 by T2 minus 1. So we are dividing both sides by T2 of numerator and denominator. So from here we get T1 by T2 equal to 1 plus 1 by COP of the reversible refrigeration, which is now equal to T1 by T2 equal to 6/5. So in case you have any more doubts, so you can follow the source. Okay, so we'll go to the next question. The actual COP of vapor absorption system compared to vapor compression cycle while working between same temperature limit is A. Less, B. More, C. Equal, or D. cannot be determined. So you can pause and think of the answer. The answer is A. The actual COP of vapor absorption system compared to vapor compression cycle while working between the same temperature limit is less. So COP of absorption system is less and COP of compression cycle is more. Okay. Now for the same refrigeration and heat rejection temperatures, the COP of vapor compression refrigeration system will be much higher than the COP of an absorption system, as a high grade mechanical energy is used in vapor compression refrigeration, while a low grade thermal energy is used in the vapor absorption system. Okay. So if you have any more doubt, you can follow the source. So we'll go to the next question. Heat is absorbed from cold chamber to produce refrigerating effect from A. Evaporator, B. Compressor, C. Expansion valve, or D. Condenser. So you can pause and think of the answer. So the answer is A. Heat is absorbed from cold chamber to produce refrigerating effect from evaporator. So it is the evaporator where we absorb the heat. Okay. So in case you have a refrigerator, then the evaporator is the inner part of the refrigerator. Okay. So with this we conclude the third part of this APSC Irrigation 2021 Mechanical Engineering paper. So we will meet next in the fourth and final part of this paper. Okay, and then we will meet for more future videos. Thank you.